Hello dear students, so welcome you all to the Brahmastra Series chemistry class, and today we are going to solve a lot of numericals. Okay, so almost I can say 40-50 numericals we are going to solve, okay, from all the three physical chemistry chapters. And one very important thing about this particular numericals are that I have taken these numericals from the PU question bank that was released by the PU board. Okay, so many of you might not be having access to that, so you can see, you can just check that. So the PU bank, the PU board has released the question bank, and from that I have picked all the numericals. Okay, so very important numericals, let us practice them. Okay, so what you have to do, you have to start with me, and I will not be solving each and every question in detail. Okay, I will be just telling you the process because that is what you should be knowing. Calculation part, since calculator is allowed, so you can just do the calculation. I will be telling you the final answer and you need to check it. Okay, so let us see the first question. Question is, calculate the molality and the mole fraction of the solute containing 3 gram of urea per 250 gram of water. Okay, so now what happened, if you want to calculate molality, so what will be the formula for molality? We know WB, that is the mass of the solute, by the molar mass of the solute into 1000, right, by molality, right, mass of the solvent. Okay, so now if I want to calculate 3 gram of urea is taken, right, so that is 3 gram of urea. What is the molar mass of urea? 60 gram per mole, okay, into 1000, okay, by what is the mass of the solvent? That is 250. Okay, so now if you solve this, you will get molality. Clear? Now next is to calculate the mole fraction. Okay, so this is about calculation of molality. Okay, next we'll go for mole fraction. Okay, now if you see in mole fraction, let us first calculate the number of moles of urea, right, given mass by molar mass, so 3 by 60. Okay, next number of moles of water, right, 250 gram of water, so given mass by molar mass 250 by 18. Okay, so now if you want to calculate the mole fraction of urea, okay, so and mole fraction of the solute, right, so solute means it is urea, so mole fraction of urea will be equal to number of moles of urea, okay, divided by number of moles of urea plus number of moles of water. Okay, so now how we can make it? So it is 3 by 60 divided by 3 by 60 plus 250 by 18. Okay, so now you can solve this part and you will be getting the answers. I will be telling you the final answers. So sorry, this is overlapping, let me erase this part. Okay, so the answer for molality will be 0.2 and mole fraction is 0.0039. Okay, so let me write down this one here. Okay, this one will be 3 by 60 whole divided by 3 by 60 plus 250 by 18. Okay, clear? Now moving towards the next question, if 22 gram of benzene is dissolved in 122 gram of carbon tetrachloride, determine the mass percentage of carbon tetrachloride and benzene. Okay, fine. So 22 gram of benzene is dissolved in 122 gram of carbon tetrachloride. Okay, determine the mass percentage of carbon tetrachloride and benzene. Okay, this is also very simple. So mass percentage, what's the formula for mass percentage? Mass of the element or mass of the compound by total mass into 100. Okay, so now if I see here 22 gram of benzene is taken. Okay, so I can write what is the mass of benzene, 22 gram, and carbon tetrachloride, that is CCl4, is 122 gram. Okay, so if I add them, I will get 144 gram total, right. So what is the percentage of first one, benzene? Okay, benzene percentage will be mass of the benzene divided by the total mass into 100. Okay, and similarly percentage of CCl4. Okay, so what is the mass of CCl4? 122, right, divided by the total mass into 100. Okay, so if I solve these two, I'll be getting the masses. So if the answer, it will be, for mass percentage of benzene is 15.28 and mass percentage of chloroform is 84.72. Okay, now let us move towards the next question. The mole fraction of helium in a saturated solution at 20 degrees Celsius is this much. So let me write down the value. Mole fraction of helium is, okay, find the pressure of the helium above the solution given the Henry's constant. Okay, 144.97 kilobar. Okay, so now if I have this formula, P of the gas is equal to KH into mole fraction of the gas. Just substitute. We have this pressure value, we have to found KH value is 144.97, right, and XE value is 1.2 into 10 to the power of minus 6. So now if you solve this, you will be getting 0.174 bar. Okay, so just check the calculation. Now moving towards the next question, that is question number 4. That the vapor pressure of a pure liquid A is 40 mm of Hg. Okay, so let me write down the value. Always whenever you read the question, okay, either highlight the values or you note down it. Okay, so vapor pressure of pure A is 40 mm of Hg at 310 Kelvin. The vapor pressure of this liquid in the solution with liquid B is 32 mm of Hg. Calculate the mole fraction of A in the solution if the mixture obeys Raoult's law. Okay, so now you see the question is saying very simple. We have the pure pressure of A. Okay, that is how much? 40 mm Hg. Now the question is saying that if you mix A and B, okay, then the pressure of the A is 32 mm of Hg. That means I can say that pressure of A, PA means in the solution with B, okay, it is 32 mm Hg. Now we have this formula, PA is equal to P naught A into XA, right. So what will be XA? PA by P naught A, right. So that is 32 by 40, right. So we can calculate 4 8s are 4 10s are, so 0.8. Okay, clear? Next question number 5. Calculate the mass of a non-volatile solute, molar mass is given, which should be dissolved in 114 gram of octane to reduce the vapor pressure to 80%. Okay, so calculate the mass of a non-volatile solute, molar mass is given, which should be dissolved in 114 gram of octane to reduce the vapor pressure to 80%. Okay, so this question is little tricky. Okay, so I can say this is little tricky question. Okay, but let us first note down the values that is given to us. The first thing is molar mass of the solute is given, right. So I can write MB. So B is always for solute, A is for solvent. So I have 40 gram per mole. Okay, then next 114 gram of octane. So if that is solute, then this will be solvent. So I have mass of solvent, that is how much? 114 gram. But I can also calculate the molar mass of solvent, right, because it is octane. So octane will be C8H18, right. 8 2s are 16, 17, 18. Alkene formula CnH2n plus 2. Okay, so 12 into 8, that will be 96, and then 18 hydrogen. So if I add them, 9, 10, 11, 114 gram per mole. Okay, so let me erase this rough work here. Okay, we got this data. Next, the vapor pressure is reduced to 100%, 80%. Means, now see, earlier it must be 100% and now it has become 80%. Okay, so what I can say, that we will assume that the P naught value, okay, the pure pressure value of this octane was 100%, and after adding this solute, okay, the final pressure became 80%. Okay, then we can just use the relative lowering formula. So what is relative lowering formula? Delta P by P naught is equal to, I can write P naught minus P by P naught is equal to XB or in presence of Xb I can also write Nb by Na, right? But here you should remember, in such type of calculation questions you can ignore Nb in the denominator. Why? Because generally you can see 114 gram is there, and the mass of the solute is generally considered to be very, very less than that of the solvent. Okay, so here I will just write this much. Okay, now let us see what all data we need. We can calculate Na now here. Na, given mass by molar mass, 114 by 114, so that is 1. Okay, so I think this is very easy now. Let us calculate. P naught value is 100 minus P value is 80 by 100. Okay, Nb will be what? Wb, which we have to calculate. Molar mass is already given to you, 40. Okay, this is what? Nb, and Na is 1. Clear? So now if I solve this, this one will become 20 by 100, okay, is equal to Wb by 40. So what will be Wb value? So you just multiply here, 800 divided by 100, so that is 8 gram per mole. Sorry, 8 gram, not 8. So it is not molar mass, right? So it is only 8 gram. Okay. Now let us see. Yeah, that will be your answer. Now moving towards the next question. The vapor pressure of a 5% aqueous solution of non-volatile organic substance at 373 Kelvin is 745 mm. Okay. Calculate the molar mass of the solute. Okay, this is also a bit, I can say, tricky question. Okay, but yes, similar questions are there in your NCERT book, so you should practice similar questions. Now the first thing here is very important, 5% aqueous solution of a non-volatile organic substance. Now when this is given, okay, 5%, this is very important to understand. What does this mean? This 5% means that 5 gram of solute in 100 gram of solution. Okay, 5 gram of solute in 100 gram of the solution. Okay, so now if you see here, vapor pressure of the solution is 745. What was the molar mass of the solute? So what information I can draw from here? Now see, you have okay, it is an aqueous solution, so I can say that, see, mass of the solute is how much? 5 gram. Okay, total mass of the solution is 100 gram. Then what will be the mass of the solvent? I can write mass of the solvent is also 95 gram, right? Because total mass is 100, 5 gram is solute, so solvent will be this one. And solvent means generally it is water in this case, right? Because it is mentioned here, it is an aqueous solution. So I can also write what is the molar mass of solvent. Because it is water, I know, so it is 18 grams per mole. Okay, this much clear. This much information we can derive from that 5% term. Now the pressure has decreased to 745, and we know generally the P naught value will be considered as 760 mm of Hg. Okay, and P value is given to you 745 mm of Hg. Okay. Next, we can calculate here the number of moles of water. So that will be what? Given mass by molar mass. So 95 by 18. Okay. And here number of moles of solute, that we don't know. Given mass is 5, molar mass we don't know. So that is your X. Okay. So now we can put it in the equation. So what is our equation? Delta P. Okay. Just let me separate this one. Yes. Delta P by P naught is equal to, I can put P naught minus P by P naught is equal to XB is equal to NB by NA, right? So now if I put this value, what is P naught value? 760, right? So 760 minus 745 divided by 760 is equal to NB. Means NB means number of moles of solute, that is 5 by X. Okay, divided by 95 by 18. Okay, so now you can just solve it. Okay, so this is 15 by 760, okay, is equal to 5 by X into, this one can go up, so that is 18 by 95. 5. Okay, so now you solve this and find the value of x, and that will be the answer will be around 0.8 gram per mole. Okay. Moving towards the next question, the vapor pressure of water is 92 mm at 323 Kelvin. 18.1 gram of urea is dissolved in 100 gram of water and the vapor pressure is reduced by 5 mm. Calculate the molar mass of the urea. Okay, again very similar question here and there. They have given you have to use the same formula, but yes, now sometimes they are asking you molar mass, something they are asking you the given mass, sometimes they are asking the pressure. Okay, based on that the question has been changed. Okay, fine. So let us again put the value. First is 92. So P naught value of water is 92. Okay. Next it is said that it is reduced by 5 mm, right? So that means your delta P value is 5 mm. Okay. Then we have urea dissolved in 100 gram of water. So mass of solvent 100 gram, right? 100 gram of water is there. So I also have the molar mass of the solvent, and that is 18 gram per mole. Okay. So number of moles of water will be how much? 100 by 18 moles. Okay, this is done. Next we have to calculate the molar mass, and we have been also given with the weight of the solute, right, which is how much? 18.1 gram. Okay, and question is asked to calculate the molar mass of the solute. Now, so you might be asking, we all know that the molar mass of the urea is 60 gram per mole, right? But you have to use this formula and calculate it. Okay, so do not just see this question and write down 60 gram per mole and come. Now see, these colligative properties are used to calculate the molar masses of unknown substances. Okay, so this is the method that is followed. So you also have to calculate it and show that the molar mass of urea is nearly equal to 60 gram per mole. Okay, so now if I use in that way, this is done. So now if I just put the formula here, okay, so we have delta P by P naught is equal to XB, or I can write like NB divided by NA. Okay, now if I substitute, okay, so delta P is 5 mm, okay, and this one is 92 mm, okay, of Hg also you should write. Okay, next, what is NB value? Number of moles of solute, we don't know, that is 18.1 divided by X, okay, molar mass, divided by the molar mass of the solvent is how much? 100 by 80. Okay, so just you have to solve this. So how much we'll get? Like this is like 5 by 92 is equal to 18.1 by X, okay, into 100 by 80. So now you have to arrange this and solve for X, and once you solve for X, you will be getting 56.7 gram per mole. Okay, so now you might be asking that urea mass is actually 60, but it is coming 56.7. So experimental data and the accurate data, there will be some discrepancy. Okay, so that is why you have to calculate it properly and get the value of X. Now you should not think that I am getting 56.7, that means calculation is wrong. It is not like that. Okay, so there will be always a difference between the experimental and the theoretical data. Okay, fine. Moving towards the next question. So we have done certain questions from your relative lowering of vapor pressure. Okay, now calculate the boiling point of a solution containing, okay, this is again a tricky question, not tricky, but yeah, something I can say little not very common type of question. Okay, little bit there is some difference. Calculate the boiling point of a solution containing 25 gram of urea, okay, and 25 gram of thiourea in 500 gram of chloroform. Okay, the boiling point of the pure chloroform is given and the Kb value is given to you. Okay, now what is the difference in this particular question? So generally when we solve question, we get only one solute, right? Only one solute is added to the solvent, but here you can see that two solutes have been added. You have added urea and you have also added thiourea. Okay, so that is why how to do this type of question. So let us first note down the values that is given to us. So for urea, mass of urea is how much? 25 gram, okay, and I know the molar mass of urea, that is 60 gram per mole, okay. Next, mass of thiourea, okay, so that is also 25 gram, and molar mass of thiourea, okay. So that we can just calculate, you have the formula, right. So NH2 CSNH2, okay. So nitrogen, 14 plus 14, 28, hydrogen, there are 4 hydrogen, right. So 1, 2, 3, 4, okay. Then carbon is 12, okay. Then sulfur is 32. So I can say 8 plus 4, 12, 13, 14, 15, 16, and then we have 3, 2, 5, 6, 7, 8, okay. So just check the calculation once again. So or else we can just think like this, 60 gram was the mass of urea, right. Oxygen is replaced with sulfur. So 60 minus the mass of oxygen is 16 plus the mass of sulfur is 32, okay. So if I just do like this, then will I be getting, so 60 minus 16 will be 10 minus 6, 4, and here I am getting 54 plus 32, yeah, I am getting the same 86, right. Yeah, so the mass is 86, so this is nothing, I was just checking, you can just normally calculate, it is 86, okay. So now we got the 86 gram per mole, okay, this is done. Now let us calculate the number of moles of urea, given mass by molar mass 25 by 60, number of moles of thiourea, given mass by molar mass, so sorry, 25 by 86, okay, mole, clear. This is done, number of moles we have calculated for both. Now what we have to do, we have to see the formula, okay. Now here you should be little bit careful how to solve. Now see, you have to now calculate N total, okay, means including both urea and thiourea, okay. So it is 25 by 60 plus 25 by 86 moles, okay. Now what else data is given to us? 500 gram. What is that? That is the mass of the solvent, okay. W solvent is 500 grams, okay. Next, what is given? Pure chloroform boiling point, that is T naught is given to you, right. T naught boiling point is how much? 61.2 degree centigrade, okay. Here a question may arise like, do we have to convert it? Yes, you can see that here it is in Kelvin, right. So if you do not convert it into Kelvin, then units will not match. So to convert it, just add it with 273. So I will get 12, 13, 334.2, right. Yeah, 334.2. So I will just erase and write down the value in case of 334.2 Kelvin, okay. And what we have to find? We have to find the boiling point of the solution, okay. So now if I just see, delta TB is equal to KB into M, okay. So now if I see here, what is delta TB? The boiling point elevation takes place, right. The boiling point of the solution will be more than the actual boiling point. So that means I can put TB minus T naught B is 334.2 Kelvin, okay, is equal to KB value is 3.63 K M inverse, okay, into molality. So for molality, what we can do, okay, let me take some space here, okay, 1 second, okay, I will write it again. We need little more space, just a minute students, okay. So let us see here, okay. Now delta TB, as I told you, TB minus T naught B, right. So this is like TB minus T naught B is equal to KB into M, I can write number of moles, right, by the mass of the solvent, okay. I have used different denotation, we have to use W of the solvent, right, mass of the solvent into 1000, right, this is the thing. So if I just write down this value here, What is TB? I have to calculate. T naught B is 334.2. Okay. Then what is KB? 3.63 K mole inverse. Okay. Into M value. Number of moles is how much? 25 by 60 plus 25 by 86. Okay. Number of moles given. Okay. Divided by, what is the mass of the solvent? 500 gram. Okay. So just we have to solve this equation and find the value of TB. So if you do this calculation correctly, you will be getting in 66.616 degrees centigrade. So you might be getting the answer here in Kelvin, then again you can subtract. Here no units are mentioned, so you can put it in any units. Okay. Next is going to question number 9. Calculate the osmotic pressure in pascals exerted by a solution prepared by dissolving 1 gram of polymer of molar mass 1,85,000 in 450 ml of water is 370 degrees Celsius. Okay, at 370 degrees Celsius. Let us first write down all the values. Okay, so mass of the solute, W of the solute is 1 gram. Molar mass of the solute is 1,85,000. Okay. Next, volume of the solvent. Okay, sorry, solution. Okay, volume of the solution is 450 ml. Okay, and temperature is given to you 370 degrees Celsius. Okay, now just you can convert it into Kelvin. So we will get 643 Kelvin. Okay, so we will be getting here 643 Kelvin. Okay, now once this is done, we can just put the formula here. Pi is equal to C into R into T. Okay, and what is the R value in such cases? R value will be, is it given to you in the question? No. So we can take 0.0821 or you can just take 0.083. Okay, liter ATM mole inverse Kelvin inverse. So please remember these units, and whenever you put with units and see how the units are getting cancelled. Okay, so you can see now for C I can put number of moles by volume in ml into 1000. Right, that is there. Then R value is, and into T should be in Kelvin. So now for number of moles, did I calculate? No. What is the number of moles of the solute? Given mass by molar mass 1 by 185,000. Right. So we can put here 1 by 185,000 into 1 by volume is 450. Okay, into this is 1000. Okay, now R value is how much? 0.083. Okay, and temperature is given to you 643. Just you can do this calculation, solve it, and then you will be getting around 30.9 Pascal. Okay. Next, moving to the question number 10. Okay, so answer is not hidden here. Okay, calculate the concentration of that solution of sugar which has an osmotic pressure of 2.46 atm at 300 Kelvin. This is very simple question. So we have been given with what? Pressure is already given to you, atm, right? And temperature is also given. Okay, we just need to find C. Okay, so pressure means osmotic pressure here. So I can just put pi is equal to C into R into T, right? So concentration then will be equal to what? Pi divided by R into T, right? Let me just put the value. What is pi value? 2.46 atm. Okay, then R value is 0.083 liter atm mole inverse Kelvin inverse. Okay, next, temperature is how much? 300 Kelvin. Okay, so now you can see we can cancel Kelvin and Kelvin. Okay, and we can also cancel atm and atm. What is left here? Mole liter inverse, right? So 2.46 by 0.083 mole liter inverse. Okay, so we will be getting 34.42 gram per liter. Okay. Next, coming to question number 11, calculate the molar elevation constant of water. Molar elevation constant means they are asking you to calculate Kb of water. It being given that 0.1 molar solution, okay, aqueous solution of a substance boiled at 100.052 degree Celsius. Okay, this is also very simple. We have delta Tb is equal to Kb into m, or we can substitute like this, T naught B, sorry, not T naught B. First will come Tb because the boiling point has increased, right, is equal to Kb into m, Kb into m. So now if I want to substitute, what is the value of Tb? Tb I have to calculate, that is 100.052 minus 100, okay, Kb, and m is here 0.1. I can just solve it. This one will be 0.052 divided by 0.1 is equal to Kb, right? So this one will be 0.52. Okay, so that's all, 0.52. Next, question number 12. The boiling point of benzene is 353.23 Kelvin when 1.8 gram of a, okay, let me first underline this data. Okay, when 1.8 gram of a non-volatile solute was dissolved in 90 gram of benzene, the boiling point is raised to this much. Calculate the molar mass of the solute. Kb is given to you. So this type of questions are generally asked in your exam. Okay, colligative properties, most of the time you are asked to calculate the molar mass of the solute. So similar question. So you should be first writing the values. We have the pure benzene, right? T naught B value is given to you 353.23 Kelvin. Okay. Next, 1.8 gram of non-volatile solute. So mass of the solute is 1.8 gram. Okay. 90 gram of benzene. Solvent is 90 gram. Okay. The final boiling point Tb is 354.11 Kelvin. Okay. Calculate the molar mass of the solute. To calculate the molar mass of the solute, Kb value is also given to you, 2.53 Kelvin kilogram mole inverse. Okay, then yes, I think all the values I have written. Now let us do the question. So we have this very simple formula, delta Tb is equal to Kb into m. If I want to extend and write this formula, delta Tb will be equal to T naught B minus Tb, sorry, not like this, Tb minus T naught B is equal to Kb into m will be what? W2 by m2 into 1000 by W1. Okay, so let us just substitute all the values. Tb value is 354.11. Okay, Tb value is 353.23. Okay, Kb value is 2.53. Okay, then m value, W2 is 1.8, m2 we have to find out 1000. Okay, and W1 is how much? 90 gram. Okay, so now if you just solve this, m2 value you can calculate, and that m2 value will be 58 gram per mole. Okay, you can check the calculation once again, but this is how you have to calculate. Okay, now moving towards the next question, a solution containing 34.2 gram of cane sugar dissolved in 500 centimeter cube of water froze at 0.374 degrees Celsius. Calculate the freezing point depression constant of water. Okay, so we have 34.2 gram of cane sugar, this is the solute, dissolved in 500 centimeter cube of water, freezing point is also given. Okay, very similar to the previous question. So we have here mass of the solute, right, W2. How much is it? 34.2 gram per, 34.2 gram is given. Okay. Next, you should be remembering the molar mass of cane sugar. Okay, that is 342 gram per mole. Okay, this is done. Next, 500 centimeter cube of water, and you know density of water is 1 gram per ml. So that means this is 500 gram, right? So what is the mass of the solvent? 500 gram. Okay. Next we have freezing point. Okay, so T naught F will be 0 degree Celsius and TF value will be minus 0.374 degree Celsius. Okay. Yes, now we can just substitute. We have delta TF is equal to T naught F minus TF, okay, because the new freezing point will be less than the initial freezing point, is equal to Kf into M into 1000 by W1. Okay. Now if you see here, what is T naught F value? 0 degree Celsius minus minus 374 degree Celsius, okay, is equal to Kf. Kf we have to calculate, okay. W2 is 3.42 and not 3.42, 34.2. Okay, 1 second. So this small mistakes you should avoid, students. Okay, into 1000 by W1 is 500. Okay. So just solve this all value and you have to get the value of Kf. So if you do that, you will be getting around 1.87. Okay. So check the calculation. Next, coming to question number 14. The solution of urea in water has a boiling point of this much. Okay. Calculate the freezing point of the same solution. Okay. Molar elevation constant, molar constants of water Kf and Kb are given. Okay. So we can say this is little tricky or different question. Okay. Fine. So now you see we have this formula, delta Tf is equal to Kf into M and delta Tb is equal to Kb into M. Now since it is written here that the same solution, that means concentration will also be same. So both the solution will have, both the equation will have the same M value. So if I just divide them, okay. So if I just divide them, we have to calculate what? Freezing point, right? So if I just divide equation 1 and 2, okay. So what will I get? Delta Tf by delta Tb is equal to Kf by Kb. Okay. Now if you see here, see what is delta Tf value? Delta Tf value is how much? See, generally we know the water boiling point is 100 and now it is 100.128, right? So that means the delta, not delta Tf, delta Tb value will be 100.128 minus 100. Okay. Delta Tf value we don't know, right? So we'll just put it like delta Tf, okay, or we can just put like this. We know the freezing point of water is 0, right? This is given in centigrade, so we'll put it in centigrade. Yes, this is there, T naught F minus Tf, and what is Kf value? 1.86 and this is 0.512. Okay. So now you can just solve this equation and you can just find the value of Tf. Okay, and Tf value will be minus 0.465. Okay. Now I think this will be the last question of solutions chapter. After that we'll be moving towards the electrochemistry chapter. Okay, this question is again very important. Okay, and this was also a similar question was asked in your KCET PYQ. Now two elements A and B form compounds having formulas AB2 and AB4. Okay, when dissolved in 20 gram of benzene, once again, we have two compounds, one is AB2 and AB4. Okay, when dissolved in 20 gram of benzene, 1 gram of AB2 lowers the freezing point by 2.3 Kelvin, whereas 1 gram of AB4 lowers it by 1.3 Kelvin. Okay, the molar depression constant for benzene is given to you. Calculate the atomic masses of A and B. Okay, little bit I'll say is a tricky question. Let us read it again. Okay, two elements A and B form compound AB2 and AB4. Okay, when dissolved in 20 gram of benzene. So if I have AB2, okay, if I take 1 gram of AB2, okay, lowers the freezing point by 2.3 Kelvin. Okay, so lowers the freezing point by 2.3 Kelvin means delta TF is equal to 2.3 Kelvin. Okay, whereas 1 gram of AB4, okay, lowers by 1.3 Kelvin. Okay, fine. Molar depression constant of benzene. So we have Kf value. Okay, so Kf value is 5.1. Okay, fine. So now how to do this question? So let us take that the atomic mass of A is small a and atomic mass of B is small b. Okay, so now here what will be the I value? If it will dissociate, we will get I is equal to 3 and here I will be equal to 5, right? So now what I will do, the molar mass here, what will be the molar mass here? So I can write M. Okay, M will be A plus 2B. Okay, and here M will be A plus 4B. Okay, now you will generate two equations. Let us see how. Now delta TF here is 2.3 Kf, okay, into M. What is the M value? Given mass is 1 gram, molar mass is A plus 2B, okay, into in 20 gram of benzene, right? So 1000 divided by 20, and since it is an ionic compound, here you have to also put the value of one second, AB2, right? So this is I value, this is Kf value, and this one, so delta TF is 2.3. This is your first equation. I hope it is visible. Now coming to the second equation, it is 1.3 is equal to 5 into 5.1 into 1 by A plus 4B into 1000 by 20. Okay, so now using these two equation, okay, two unknowns are there, you have to calculate the value of A and B. Okay, once you calculate the value of A and B, then just substitute and calculate the molar masses of AB2 and AB4. Okay, they are not asking you, they are only asking you to calculate the atomic masses of A and B. So you just have to calculate A and B value. Okay, so you have to solve this equation, and once you solve this, you will be getting 25.59 and 42.64. Okay, please do this calculation and let me know if you are getting the answer or not. Okay, fine. Now moving to the next question, next chapter, that is electrochemistry. So the numericals from electrochemistry. Resistance of a 0.01 N solution of an electrolyte is 100 ohm. Calculate its. First I will be only telling the formula. Conductance symbol is G, right? Conductance is the opposite of resistance. So I can say conductance or G is equal to 1 by R or 1 by 100 or 10 to the power of minus 2 ohm inverse, that is S. Next, conductivity. Conductivity is what? That is your one second. Okay, conductivity is given, right? So we know that lambda is equal to kappa into 1000 by C, right? So here we need this conductivity value. Equivalent conductance is given, that is 0.01. So I can put 10 to the power of minus 2 is equal to kappa value I have to find out into 10 to the power of 3 by C value is 10 to the power of again minus 2, right? So if you see here, this is minus 2, it will go 10 to the power plus 2, 10 to the power plus 5, it will again come here. So I think it will be 10 to the power of minus 7, I think, but we will check the calculation. Next is resistivity. So again C, resistivity will be what? 1 by conductivity. Okay, resistivity is 1 of kappa. So that will be 1 of 10 to the power of minus 7, that is 10 to the power of 7. Okay. Next, what we have? Okay, cell constant is also given, but I think we do not need that. We can directly calculate in this way. Let us see the answer. 1 second. Okay, so here you can see 10 to the power of 0 1. Okay, B answer, I have think something wrong is here. I told you, let us check this calculation once again. Okay, I think some mistake I did. Lambda is 0.01. Okay, sorry, molar conductance. Okay, so here is a mistake, student, sorry, this value is not given to you. One second. Okay, that is why we have to use, just a minute. Yeah, so the second one, I did a small mistake here because lambda m is not given, right? That is, resistance is given and concentration is given. Okay, so we know this one. See, I have that 1 by R is equal to rho into L by A, right? I know this formula, and I can write kappa or 1 by rho. If I take this one here, that is 1 by rho, or kappa is equal to 1 by R into cell constant or L by A. So 1 by R is what? 10 to the power of minus 2. L by A is 1. So that is why this is 10 to the power of minus 2. And next, this one will be opposite of this one. So this is 10 to the power of 2 and 100. Okay, I hope I got you little confused, sorry for that. Okay, next question. For the standard cells Cu to Cu2 plus and Ag plus to Ag, E0 values are given to you. Okay, identify the cathode and the anode as the current is drawn from the cell. So if you now see, the one whose reduction potential is more will behave as the cathode. Okay, so reduction potential of silver is 0.8 and for copper it is 0.34. Silver reduction potential is more, silver will behave as a cathode. Okay, so first one, cathode will be silver, then automatically anode will be copper. Okay, next, write the reaction taking place at the electrode. So copper is what? Anode. So what will be the reaction? Oxidation, Cu to Cu2 plus 2 electron. This is what? This is at anode. Okay, and at cathode, silver is undergoing reduction, right? So Ag plus electron is equal to Ag. Done. Next we have calculate the standard cell potential. Now let's see the next question. Calculate the standard electrode potential. So for electrode potential, it is E0 of cathode minus E0 of anode. E0 values are also given to you. So this is again a very super easy question, my dear students. So we can do like E0 of cathode minus E0 of anode. So what is it? Cathode is your silver one, right? So silver value is 0.8 minus 0.34. So it will be 0.46, right? So yes, that is there. Next, calculate the potential of a hydrogen electrode in contact with a solution whose pH is 10. Okay, so this is again a good question and it is there in your NCERT in text question. Okay, so first of all, hydrogen electrode, if you just see, it is like this. Okay, H plus 1 electron gives you half H2 gas. Okay, so now if I want to write the reduction potential, and H plus concentration is 10 to the power of minus 10. Okay, so pH is 10, that means concentration will be 10 to the power of minus 10. Now how am I getting that? So if you know, pH is equal to minus log of H plus, right? So we know that pH is equal to 10, so that is minus log of H plus. Okay, so now what will come? Minus 10 is equal to log of H plus. Okay, so H plus will be equal to 10 to the power of minus 10. Okay, so that is the concentration of H plus. So now we know E of the cell will be equal to E0 minus 0.059 by N log of, okay, here pressure of H2, okay, divided by concentration of H plus. Okay, so now if I just substitute the values here, E of the cell I have to calculate. Okay, this is, it's not actually cell, it is electrode. Okay, so I have to calculate standard electrode for hydrogen is 0 minus 0.059, here N is 1, okay, log of 10 ATM you can just take as 1 and H2 10 to the power of minus 10. Okay, so this one goes up 10 to the power of 10 and then you multiply, that will become 10, so you will get minus 0.0, not 0.0, sorry, 0.59 volt. Okay, this is this one. Next, question number 4. Calculate the EMF of the cell in which the following reaction takes place. Okay, E naught of the cell is given to you. Okay, so you have to just calculate the EMF. So cell reaction is given, so we can just write down first E of the cell, okay, is equal to E naught of the cell minus 0.059 by N log of. So you can see here on the product side, nickel constant, nickel is the ion. So in the Nernst equation we always consider the ions only, right? So nickel is an ion here, so that is log of nickel 2 plus divided by silver is Ag, okay, Ag plus square. So now if I see here, E naught value is 1.05 volt, okay, minus 0.059 by N, N is 1, okay, sorry, N will be 2, you can see here 2 electrons, here also 2 electrons, so that is 2 log of Ni2 plus is 0.16, okay, and Ag plus is 2 into 10 to the power of minus 3 whole square, okay. So now you can just solve this and calculate the value of E, okay. Once you do this calculation, you will be getting 0.91 volt. Coming to next question, the cell in which the following reaction occurs, okay, that is given, E naught value is given to you. Calculate the standard Gibbs free energy change and the equilibrium constant of the reaction, okay. So this was also very important question. We know delta G is equal to minus NF E naught of the cell, okay. So in this reaction you can see Fe3 plus to Fe2 plus, 1 electron, but there are 2 Fe, so 2 electrons, right. So N value is 2, Faraday 96500, E naught of the cell is 0.236 volt, okay. So if I solve this, you will be getting the value of delta G, okay. And next is your equilibrium constant, okay. So what is the formula for equilibrium constant? It is equal to minus 2.303 RT log of K, right. So temperature is also given, delta G you would have calculated here, substitute that here, okay. So that is minus 2.303, R is, here you can put R is equal to 8.314 into temperature is 298 log K, okay. Once you solve this, you will be finding the value of K as well, okay. So Gibbs free energy will be that much and equilibrium constant value will be 9.6 into 10 to the power of 7. Okay, next question, the molar conductivity of 0.025 mole liter inverse methanoic acid is given to us this much. Let me write down this value. Molar conductivity of, so lambda m value is given as 46.1 s centimeter square mole inverse, okay. And then concentration is given 0.025 mole liter inverse, okay. Calculate its degree of dissociation and dissociation constant, okay. We have to calculate alpha and Ka, okay, these two. Given that lambda naught, okay, fine. So let us now do, first we know alpha, for that we need what? We need alpha value is, if you know the formula, lambda m by lambda naught m, right. So what is lambda naught m formula? H plus and HCOO minus, right. So you have to just add these two. So what is lambda naught m of HCOOH? That is lambda of H plus lambda of HCOO minus, and that is equal to H plus is 349.6 and this one is 54.6, okay. So now just we will add 6 plus 6 12 9 plus 1, 10 plus 4, 14. Then I have 4 plus 1, 5 plus 5, 10. 3 plus 1, 4. This is done. Okay. Clear? So lambda naught I got. Lambda m value is also there with me. So I can just put 46.1. Okay. This is lambda m value divided by 404.2. Okay. So this will give me alpha value. Now what is the value of Ka? Ka formula is C alpha square. Okay. So C value is your 0.025. Okay. This is C, and alpha value is 46.1 by 404.2, this one square. Okay. So if I solve this, I will be getting alpha value this much and Ka value this much. Okay. This formula is little less common, so you should be revising this one. Okay. Next, if a current of 0.5 ampere flows through a metallic wire for 2 hours, how many electrons will flow through the wire? Okay. So we know that Q. Okay. Now Q is equal to what? I into T. Okay. So current is 0.5 ampere and time is 2 hours, that means 60 minutes, that means 60 seconds. Okay. So this one will give you some, so I can solve this. 6 6 is 36, 36 into the 2 into 36, right? So this much is 2 5s are, this is 10, 1. So I'll get 36 coulomb, 3600 coulombs. Okay. Now we know that how many electrons are flowing. So we know that 96500 coulombs is for 1 mole of electrons, or I can say 6 into 10 to the power of 23 electrons. So for 1 coulomb, how many electrons will be there? 6 into 10 to the power of 23 divided by 96500. Now next we have, suppose 3600 coulombs. Okay, so that will be 6 by 96500 into 10 to the power of 23 into 3600. Okay. So now if I just solve it, you can cancel this one. Okay. Now if you solve this all, you will be getting 2.246 into 10 to the power of 22 electrons. Okay. Next we have the resistance of a conductivity cell containing this much. So let me write down first. Concentration is 0.001 m. Okay. At 298 Kelvin is 1500 ohm. Resistance is 1500 ohm. Okay. What is the cell constant if the conductivity, you have to ask cell constant. Okay. If the conductivity of 0.001 m KCl solution at 298 Kelvin, okay, conductivity value is also given to you. Conductivity of the same solution at 298 Kelvin is 0.146, okay, 0.146 into 10 to the power of -3 s centimeter inverse. Okay, fine. So you have to find what? Cell constant. So we have just discussed the formula for cell constant. So we know that kappa is equal to 1 by r into L by A. Right, this is the cell constant formula. Now kappa value is 0.146 into 10 to the power of -3, and this is 1 by 1500 into L by A. So just 1500, if you multiply this side, -3 into 1500 is equal to L by A. Okay. So now if you solve this, you will be getting around 0.219 centimeter inverse. Okay. Clear? Next, okay, how this unit is coming, if I just see. So if you see here, kappa value is what? S centimeters inverse. Okay. And now this is here ohm, right? So now this one comes as ohm, and S can also be written as ohm inverse. So this one will get cancelled, and you have left with only centimeter inverse. Next question, how much electricity in terms of Faraday is required to produce 20 gram of Ca from molten CaCl2? Okay. So from molten CaCl2, it is in the form of Ca2 plus 2 electron will give you Ca, right? So that means what? 2 Faraday, okay, 2 moles of electrons means 2 Faraday gives you 40 gram of calcium. Molar mass of is 40 gram. So if I want 20 gram means half of this, here also it will be half, so that is 1 Faraday. So here how much I will require? This one will be 1 Faraday. Next, 40 gram of aluminium from Al2O3. So if you see, aluminium is in 3+ oxidation state here, right? So 40 gram of Al from molten Al2O3. So if I see like this, it is like this, okay? So the 3 Faraday gives me 27 gram of aluminium, okay, or I can say 27 gram of aluminium. 27 gram of aluminium is produced by 3 Faraday. So 1 gram will be 3 by 27 Faraday, okay, and then 40 gram will be produced by 3 by 27 into 40, right? So if I just calculate, 3 9s are 27 and 9 4s are 36, 4, so 4.4 Faraday something will be getting, okay. Okay, next is question number 10. A solution of nickel nitrate is electrolyzed between platinum electrodes using a current of 5 ampere, okay. Current is 5 ampere and time is 20 minutes, okay. So you should always convert it into seconds. So 20 into 60 seconds. What mass of nickel is deposited? So this is very simple question, but here something we should be knowing is the molar mass of nickel, which is not given, okay. So molar mass of nickel should be given to you in the question paper, okay. So even you should remember that, okay. Okay, so molar mass of nickel is, one second, okay. So molar mass of nickel is 58.6 gram per mole, okay. So now we can calculate M is equal to Z into I into T, right? What is Z here? Z is equivalent mass or electrochemical equivalent, and nickel, if I see, it is deposited in like this, right? Ni2 plus 2 electrons gives you nickel. What is N value then? N value is 2. So if I just calculate, here it will be molar mass, okay, divided by N into 96500, okay, into I into T. So molar mass is 58.6, N is 2, 96500, okay. I value is how much? I value is 5 ampere, right? Time is 1200, okay. So now if I just, time is 1200, okay. So now if you just calculate it and solve it, then we will be getting around 1.825 grams, okay. Fine. Next, question number 11. An electric current of 100 ampere is passed through a molten liquid of sodium chloride for 5 hours. Calculate the volume of chlorine gas liberated at electrode at NTP. This is also very important question, okay. So now see very carefully. First of all, we can see that, okay, first is current given 100 ampere, okay, and next we have time is given 5 hours, okay. So first let us calculate the mass of chlorine deposited. So now if you see, mass is again equal to Z into I into T. Now here chlorine reaction is like this, 2Cl minus will give you Cl2 plus 2 electrons, okay. So now Z equal to 2 and this chlorine mass is how much? 71 grams, right. So now we can say that molar mass is 71, N is 2 into 96500, current is how much? 100 ampere, okay. Time is 5 into 3600, okay. So now you can just cancel whichever is possible, okay. So I can cancel this one, I can cancel here, I can cancel here, I think 5 3s are 15, 5 9s are 45 plus 1 40, yeah. So I got 71 by 193 into 1800, okay, fine, this is there, okay. Mass deposited, okay. Now coming to talking about the volume part. So how to calculate that one? Now see, if I have, like I can say 71 gram mass, okay, 71 gram mass, okay, that is equal to 1 mole, the chlorine 1 mole, or I can say 1 mole is equal to 22.4 liter, right. But if it is 1 gram, then it is 22.4 by 71 liter, okay. But if it is 71 by 193 into 1800 grams, then how much liter it will be? 22.4 by 71 into 71 into 1800 divided by 193, okay. So let us see, just calculate this one. 10, 11, 12, 13, okay. So now if you solve this, you will be getting around 208.91 liter, okay, that's the answer. Now coming to question number 12, okay. In an electrolysis experiment, a current was passed for 5 hours through a 2-cell connected in series. So this is from Faraday's second law, okay. The first cell contains a salt of gold and the second cell contains a salt of copper sulfate, okay. 9.85 gram of gold was deposited in the first shell. If the oxidation number of gold is +3, find the amount of copper deposited on the cathode in the second cell, okay. So just imagine that we have to use the Faraday's second law. So first of all, what is given? Current was passed for 5 hours through 2 cells connected in series. So we have been given with T, that is 5 hours, okay. Next we have given gold salt. So there is gold and copper. 9.85 gram of gold was deposited. So mass of gold was 9.85 gram, okay. In the first cell, if the oxidation number of gold is +3, calculate the amount of copper deposited, okay. So to calculate this one, we can use directly like this. See, mass of copper deposited by mass of gold deposited is equal to equivalent weight of copper divided by equivalent weight of gold, okay. So 1 second, weight of copper, okay. So now equivalent weight of copper will be what? Okay, copper, if you know how does it reacts, copper 2 plus gets 2 electrons to give you copper, right. So equivalent weight is nothing but molar mass by n factor. So molar mass is 63.5 divided by 2, okay. Then equivalent weight of gold, so equivalent weight of gold, that will be molar mass of gold divided by, here you can see gold oxidation number is told to you 3, that means what? Au plus 3 electrons will give you Au, right. So it has to gain 3 electrons, right. So gold mass is 197, okay, divided by 3, okay. So now we can substitute this value. So mass of copper I have to find out, okay. Mass of silver deposited was mass of gold deposited was 9.85 gram, okay. Equivalent weight of copper is 63.5 by 2 and equivalent of gold is 197 by 3, okay. So if I solve this and I calculate the mass of copper deposited, it will be 4.76 grams, okay. Next, how long has a current of 3 amperes to be applied through a solution of silver nitrate to coat a metal surface of 80 centimeter square and 0.005 centimeter thick layer? Density of this much is given, okay. This is also a bit tricky question, okay. So this is used to calculate the what I'll say, this type of question you have to first calculate the mass required, okay. So now see, we have to coat a metal rod, okay, which is like this, okay, it is like this, and this thickness is given to you how much? Metal surface is 80 centimeter. So this surface is 80 centimeter and the surface is 80 centimeter and the thickness is given to you 0.05, okay. This thickness is 0.005, okay. So now I can just calculate, okay. So I can just calculate the volume of metal required to coat the complete, the volume of the rod. Okay, so that will be area into height, so it is like 80 into 5 into 10 to the power of minus 3. Okay, so 400 into 10 to the power of minus 3, so that is like 0.4. Okay, 0.4 centimeter cube. This is the volume of the metal required. Now after that we also have density. So density is equal to mass by volume. So mass is equal to density by volume. So density is 10.5 gram per centimeter cube and volume is 0.4 centimeter cube. Okay, so if I just multiply, 4 5s are 20, 4 zeros are 2, 4 1s are 4. Okay, so we will get 4.20 gram. Okay, yeah, 4.20 gram. So mass is done. Now we can use this formula, M is equal to Z into I into T. Okay, silver we want to deposit, right? So silver we have to deposit, mass of the silver is 108, like molar mass of the silver. So mass how much required? 4.2. Okay, silver mass, if you see, silver gets reduced like this. Okay, that means number of electron is 1, so that is 108 by 1 into 96500. Current we have to see, that is 3 amperes. Time we have to calculate. So if I just solve this and calculate, time I will be getting is around 125 seconds. Okay. Next is question number 14. So here we are given a saturated solution of silver chloride at 20 degrees Celsius has conductivity of 3.41 into 10 to the power of minus 6 S centimeter inverse. The conductivity of water used was 1.6 into 10 to the power of minus 6 S centimeter inverse. Determine the solubility of silver chloride moles per liter. Okay. So now if you see, we have conductivity of pure silver AgCl, if I want, that will be equal to conductivity of AgCl solution, okay, minus conductivity of water, okay, minus the conductivity of water. Okay, so now if I solve this, okay, 3.41 into 10 to the power of minus 6, okay, minus it will be 1.6 into 10 to the power of minus 6. Okay, so now if you solve this, 3.41 minus 1.6, okay, we will get 1.81. Yeah, 1.81 into 10 to the power of minus 6. Okay, so this is what? This is the value of the conductivity of pure AgCl. Okay, so now we have lambda naught m is equal to kappa into 1000 by solubility, right? Now lambda naught m value is given to you in the question, 137.2. Kappa we calculated 1.81 into 10 to the power of minus 6 into 1000, right, divided by S. So if I just solve this, S will become 1.81 into 10 to the power of minus 3 divided by 137.2. Okay, so now if you solve this, you will be getting answer around 1.31 into 10 to the power of minus 5. Okay. Now moving towards the next question, calculate the quantity of electricity that would be required to reduce 12.3 gram of nitrobenzene into aniline. So first of all, you should be knowing the reaction here. So it is C6H5NO2, okay, is getting converted with 6H plus and 6 electron to give you C6H5NH2, okay. So that is converted from then we have plus 3 H2O. Okay, so reaction is like this. So 6 moles of electrons is required. Okay, and what is the molar mass of this one? That is 123 grams. Okay, so now see what I can say, that for reducing 123 gram of nitrobenzene, okay, how much Faraday is required? 6 Faraday, or I can say 6 into 96500 coulombs are required. Now for 1 gram and for it is 12.3 gram. 12.3 gram means divided by 10. So if I just solve it, it will be 6 into 96500 coulombs. Okay, so let me just solve it. 600, 6 5s are 30, 6 6 are 36 plus 3 39, 6 9s are 54 plus 3 57. This much coulomb. Okay, but now here you see that the current is only 50% efficiency. Means how much current you give, the charge it will deliver will be half of that. So if I want this much coulomb, then the charge that I should give should be double of that, because it will reduce half and then this much charge will be delivered. So the current that is required, will be double of this one, because it is 50% only efficient. So 2579000, which is equal to 2 9s are 18, 2 7s are 14 plus 1 15, 2 5s are 10 plus 1 11 and 000. Okay. Now the question is asked how much energy it will consume. Energy consumed will be equal to EMF, okay, into the charge. Okay. So EMF is how much? 3. You are giving 3 volt. 3 into this one, 115800. Okay. So 3 8s are 24, 3 5s are 15, 16, 17, 3 1s are 3 plus 1 4, 3 1s are 3. Okay, this much we will get. Okay, so let me just erase this one. 1 second. So you can see here, current required is 57900. Energy consumed will be EMF into quantity. So just you have to multiply. Quantity of electricity will be twice of this one, right? So I will be just writing here. I'll solve this one. Quantity of electricity. Quantity of electricity is equal to 2 times of 57900. Okay. This was a little tricky question. Next question number 16. 2 students use the same stock of solution of zinc sulfate and a solution of copper sulfate. The EMF of one cell is 0.003 volt higher than the other. The concentration of copper sulfate in the cell with higher EMF value is 0.5 m. Find out the concentration of the copper sulfate in the other cell. Okay. 2 students use the same stock of zinc sulfate and a solution of copper sulfate. Okay. The EMF of one cell is 0.03 volt than that of the other. The concentration of copper sulfate in the cell with higher EMF is 0.5 m. Find out the concentration of copper sulfate in the other. Okay, we have to use the Nernst equation for this one. So now see, okay, we have first one. How can we do this? We'll write 2 equations. So for example, we have the first one, okay, the higher one. Suppose E1 is equal to E naught of the cell minus this 2.303 R by RT is told you to take as 0.06. N will be 2 here, log of, okay, log of Zn, how will this equation come? Zn 2 plus by copper 2 plus, right? Okay. Suppose this one is the one with the higher value. Okay. So in this case, what will be the value of copper? So here the copper value is 0.5 m. Okay. Just I am putting. Now E2 is the one where the value is smaller. So here E naught minus 0.06 by 2 log of, okay, Zn2 plus by x. Right, this value I don't know. Now the value of E1 minus E2 is given to you. How much it is? 0.03 volt higher. So if I do E1 minus E2, then what I'll be getting? E naught will get cancelled. So I will write like this. Okay, let me write like this. E naught minus 0.059 by 2 log of Zn2 plus by 0.5. Okay, this one minus E naught minus 0.059 by 2 log Zn2 plus, okay, by x. One second. Okay. So now what will happen if you just use this negative sign? So what I will get, E naught, okay, E naught minus 0.059 by 2. So this E naught and this E naught will get cancelled, right? E naught will get cancelled. So I am not writing that. I will write only the values that will remain. Okay. So here it will be minus 0.059 by 2 log Zn2 plus by 0.5 minus, okay, this minus will become plus 0.059 by 2 log of Zn2 plus by x. Okay. So now what I can do is I'll take this 0.059 out common. Okay. So 0.059 by 2 is common. Now here what I have, minus log of, okay, Zn2 plus and log A minus log B. So this is like this, minus log of 0.5. Okay. Then I have only taken this one common, so I have plus log of Zn2 plus minus log of x. Okay. I hope you are getting this one. Just I have expanding this one, right? So now see, minus is there, then this one is log A minus log B, then this plus is there, then again log A minus log B. So now if you see, just you can expand it, this one minus log Zn plus log Zn, this will get cancelled, and what is here left with, plus log 0.5 and minus log x. So you are left with here 0.059 by 2. Okay. Here we have log of 0.5 and minus log of x. So this can be written it like this also. I can yes, so I can write it like one second, log 0.5 by x. Okay, and this value on the left hand side was 0.03. Okay, so you can just check now, is it correct or not. So now after that you just multiply, take the antilog and get the value of x. So if you do like this and calculate the value of x, you will be getting around 0.05. Okay, clear? Fine. Next, coming to the next question, the molar conductivity of acetic acid solution at infinite dilution is given to you. Calculate the molar conductivity of 0.01 molar acetic acid solution given that the dissociation constant of acetic acid is this much. Okay. Fine. So we have been given with lambda naught m. Okay. What is that value? 390.7. Okay. Next we have to calculate the molar conductivity of 0.01 we have given acetic acid. For this one we have to calculate molar conductivity given that the dissociation constant, okay, is 1.8 into 10 to the power of minus 5. Okay. So here we have to go reverse. Okay. How to do this question? See, we know that Ka is equal to C alpha square, and I know Ka is equal to C into lambda m by lambda naught m square, right? Now I think I can get this lambda m value, all other values are given. So Ka is 1.8 into 10 to the power of minus 5. Okay. Then C value is 0.01. Okay. Lambda m I have to calculate. Lambda naught is 390.7 square. Okay, so if you solve this, you will be getting lambda m value, and that is what you have to calculate, and once you calculate it correctly, you will be getting this much. Okay, fine. Next, how many grams of chlorine can be produced by the electrolysis of molten sodium chloride, the current of 1 ampere for 15 minutes. Okay, fine. How many grams of chlorine will be removed? So just you can calculate m is equal to Z into I into T, right? So Z is what? Molar mass of chlorine is 7, 2 into 96500 into I is how much? 1 ampere, time is 15 minutes into 60 seconds. Once you calculate this, you will get the mass of chlorine that is deposited. Now how to calculate the number of chlorine? You can convert this mass to number of moles and then multiply with Avogadro number, that will give you the number of chlorine atoms, right. So you can see mass will be this much. So I am telling you this one will be 0.331 gram. Then what will be the number of Cl2 molecules, right. So that will be what? Number. So first moles, or I can just calculate number of Cl2 molecules. First you should convert it to moles. So given mass by molar mass, this is number of moles into Avogadro number. So that will give you the total number of molecules. Okay, now we will move towards the last chapter, that is chemical kinetics. So I know a lot of questions we have already solved, little tiring, but yes, this is one shot. You can do this much revision of numericals and you are done for the physical chemistry numericals. Okay, so let us quickly proceed now. The decomposition of N2O5 in CCl4 at 318 Kelvin was studied. Initially the concentration of N2O5 is 2.33 and after 184 minutes it was reduced to 2.08. The reaction takes place according to the equation given. Calculate the average rate in terms of seconds. Okay, so if you want to calculate the average rate, that will be what? Initial concentration minus final concentration. So 2.33 minus final concentration is 2.08, right, divided by 184 into 60, okay, divided by 184 into 60. So this if you solve you will get. Next is what is the rate of production of NO2, okay, so this is average rate of what? N2O5. So now if I just see this reaction, so what I can write is minus 1 by 2 of d N2O5 by dt is equal to 1 by 4 of dNO2 by dt, right. So if I just want to calculate here dNO2 by dt, okay, I'll come this side. So if I just want to calculate dNO2 by dt, then it will become 4 will go that side. So I can write 2 times of dN2O5 by dt, okay. So whatever value you get here, multiply here with 2, then you will be getting the answer, right. So if you see here, this one is coming 2.22, 2 times of that will be 4.44, okay. Next question, the initial concentration of N2O5 in the following first order reaction was this much and at constant after 60 minutes was this much, calculate the rate constant. So first order reaction, simple equation you have to use. So just first let us write down all the values. Initial concentration, so A naught value, okay, is 1.24 into 10 to the power of minus 2. A naught value, then A value is 0.2 into 10 to the power of minus 2, okay. Then we have K value is how much? K value we have to calculate, sorry, time is 60 minutes, okay, fine. We can use the first equation, K is equal to 2.303 by T log of A naught by A, okay. So that is 2.303 by 60 log of A naught is 1.24 into 10 to the power of minus 2 divided by 0.2 into 10 to the power of minus 2, okay. So if you solve this, you will be getting the answer, which is 0.0304 minute inverse. Okay, next coming to question number 3, this is very important question I will tell, okay. So in the gaseous phase, okay, so we have this reaction 2N2O5, okay, gives 2N2O plus O2, right. Is the reaction balanced? Oh, 2N2O4, yes, fine, right. So now you see at time equal to 0. So when the time is 0 means no reaction has started, no pressure, no reaction has started. At that time these two components will be completely 0, right. So the total pressure will be the pressure of N2O5, that is 0.5. Now as the reaction started at 100 seconds, so what will happen? From 0.5, 2 molecules will be gone, so minus 2x. Now 2x gone, so here 2x will form and here x will form, right, based on the stoichiometric coefficient. So what is the total pressure at 100 seconds, that is 0.5 minus 2x plus 2x plus x. So that is equal to 0.512. 1 second. 0.512. So I can say that the total pressure, that is 0.5 plus x, is equal to 0.512. So what is x value then? 0.012. Okay. So this is the value of x. Next, what we have to do? We have to see the pressure of N2O5 at 100 seconds. So pressure of N2O5 at 100 seconds. That will be what? 0.5 minus 2 into x. So if I solve this, we'll get minus this value. So we will get here 0.500 and 0.024. Just you can see here, just I subtracted this one. Okay. So it is 0.0476. Okay, so we got the pressure of N2O5 and initial pressure of N2O5. So now you can just easily calculate K. 2.303 by T is 100 seconds, log of initial pressure is 0.5, okay, and final pressure is 0.476. Now if you solve this, you will be getting around 0.00049. Okay. Now moving towards the next question, first order reaction, K value is given, half life of the reaction, this is very simple, 0.693 by K, right. So that is 0.693 by 5.5 into 10 to the power of minus 14. So if you just substitute this and solve this, you will be getting the answer here. Now next question, a first order reaction has a rate constant given, how long will 5 gram of this reactant reduce to 3 gram? Okay, this is also a simple question. So you have initial concentration, you have final concentration. So I can write A naught is 5 gram, right, and A is 3 gram, okay, and then you have the rate constant of this much, okay, and you have to calculate time. So time is equal to 2.303 by K log of A naught by A. Just substitute the value 2.303. What is K value? 1.15 into 10 to the power of minus 3 to log 5 by 3. Okay. So log 5, log 3 values you should remember. So if you solve this, you will be getting 444 seconds. Okay. Next, time required to decompose SO2Cl2 to half of its initial concentration is 60 minutes. If the decomposition is a first order reaction, calculate the rate constant of the reaction. Okay. So we know K value we have to calculate. So that is 0.693 by T half, right. So that is 0.693 by T half is 60 minutes. So just you have to solve this and you will get this answer. Okay, so simple and easy question. The rate constants of a reaction at 500 and 700 Kelvin are 0.02 and 0.07 second inverse respectively. Calculate the values of EA. Okay, so this question if you see is very simple. You just have to note down first temperature is 500, temperature is 700 Kelvin, K1 is 0.02 and K2 is 0.07. Okay. So now we have this formula, log K2 by K1 is equal to EA by 2.303 R, okay, T2 minus T1 by T1 into T2. Okay. So now if you see log K2 by K1 is 0.07, okay, divided by 0.02. EA divided by 2.303, R is 8.314 into T2 is 700 minus 500 divided by 700 into 500. Okay. So now if we solve this, this activation energy value will be coming around 18.2 kilojoule. Okay. Fine. Next, coming to question number 8, the first order rate constant for the decomposition of ethyl iodide by the reaction at 600 Kelvin is given to you, right? K value is 1.6 into 10 to the power of minus 5 second inverse. Okay. Then we have its activation energy is given to us, that is 209 kilojoule per mole. Okay. Calculate the rate constant of the reaction at 700 Kelvin. Okay. So this one as was at 600 Kelvin. Okay. And the temperature is 700 Kelvin, and we want to calculate K2 for this one. So now if you have log K2 by K1, okay, is equal to EA by 2.303 R, okay, T2 minus T1. So, okay, let me not substitute this one first. We'll write the formula again, T2 minus T1 by T1 into T2, okay. So now, here if I get log of K2 by K1, right, so that is I can say K2 we have to calculate, K1 is 1.6 into 10 to the power of minus 5. Next EA we have to calculate, EA is given to us, okay, EA is also given, right, so 209 kilojoule, okay, so 209 kilojoule, okay, per mole. Then 2.303 into 8.314, next T is 700 minus 500 by 700 into 500. Okay. So now if I solve this and then calculate the K2 value, it will be coming around 6.36 into 10 to the power of minus 3 second inverse. Okay. Now coming to question number 9, the rate of the chemical reaction doubles to an increase of 10 K in absolute temperature from 298 Kelvin. Calculate the EA. Okay. Okay, so the question is saying that if you increase the temperature by 10 K, okay, then the rate of the reaction also doubles. Okay, so I can say that suppose K1 value is suppose K, then K2 value will be 2K, and at this temperature T1 is 298 Kelvin, okay, and T2 will be 10 times increase of 10 K means 298 plus 10 will be 308 K. Okay. Then we have activation energy we have to calculate. So we have here log of K2 by K1 is equal to EA by 2.303 R 8.314 T2 minus T1. Okay, I am not writing the formula again, just I am solving it. So you need to, yes, just you have to solve, put the values and put the value of EA. Okay, next you will get question number 10 here. The rate constant for the first order decomposition of H2O2 is given by the following equation. Okay, calculate the EA for this reaction and at what temperature will its half life period be 256 minutes. Okay, now see here, if I write this equation like this, log K is equal to log A minus EA by 2.303 R into 1 by T. Okay. So now you see the question is given, calculate the EA for this reaction. Okay. So now we have this, if and the given equation is log K is equal to 14.34, okay, 14.34 minus EA by 2.303 R to 1 by T. Okay. Now you see this one, this okay, not this one, sorry. This is 10 to the power of 4 K by T. Okay. So now you can see this equation is equal to this one. So I can say that EA by 2.303 R, okay, is equal to 10 to the power of 4. So now EA will be equal to 2.303, okay, into 10 to the power of 4 into 8.314. If you solve this, you will get the value of EA. Okay. Next, at what temperature will its half period be 256 minutes? Okay. So for this, what we have to do, we can just substitute this one, right? The question is asking at what temperature the half-life will be 256 minutes. So now we know that, see, K is equal to 0.693 by T half, okay. So that means 0.693 by 256, okay. So now we have got this one also, we got the value of K. Now at what temperature will its half life period be? 256 minutes. So we got this K value. Now the question is asking at what temperature will its half-life period be? 256 minutes. So when the half-life period is 256 minutes, at that time the K value we got. Now just substitute all this here and calculate the temperature. So what is log K value? Log K will be 0.693 by 256 is equal to 14.34 minus 10 to the power of 4K by T. Now if we solve this and calculate the T value, we will get the answer. So I think this is overlaying, okay. So let me just erase this part, I will write it separately, okay. So you can see here EA value we got here, from this equation we will get EA value, K value will get from here, and after substituting this you will get the temperature value also, right. So here I can say I will get log K value is how much? 0.693 by 256, okay, is equal to EA by, this is 14.34, right. So we do not have to put this one. So that is 14.34, okay, minus 10 to the power of 4 by T, okay. Let me just erase this one, okay. So that is what you have to find the value of T here, clear? Okay, now coming to another question here, that sucrose decomposes in acid solution into glucose and fructose according to the first order rate law with T half is 3 hours, okay. So T half is 3 hours. Now what fraction of sample of sucrose remains after 8 hours? Okay, this is very simple. T half is given, so I can calculate K value, okay. Next, time is asked in the question, 8 hours, okay. And what fraction will remain after? So you have to just use the first law, K equal to 2.303 by T log of A naught by A, okay. So now K will be equal to how much? We will have 0.693 by 3, okay, 2.303 by time is 8 hours log of A naught by A, okay. So now if I solve this and just calculate A naught by A, that will be the fraction, 0.158, okay. Fine. So yes students, that's all in this class. So we have solved a lot of numericals, and I hope that these many numericals if you solve, then definitely you will get confidence and you can score that 9 out of 9 from the numerical sections, okay. So that's all students, and if you like this video, do not forget to subscribe the channel. Thank you for watching and see you soon in the next class.